We are now moving on, graduating to two-dimensional kinematics, which, as it sounds like, things can now move forward and back and up and down at the same time, not just in one dimension. So there can be a lot of examples of two-dimensional motion. I mean, imagine a air hockey puck bouncing around on an air hockey table. That is moving in two dimensions, and you can analyze it with kinematics of two-dimensional motion. But typically, we focus on projectile motion when we're studying two-dimensional motion. I'm not sure why we always do that, but it's a good example of two-dimensional motion, and it's a little bit fun because projectiles include doing things like launching cannons, right? So I want to just briefly talk about some of the underlying principles governing projectile motion. A projectile is any object that is essentially flying through the air with no significant forces acting on it except gravity. In fact, we are going to assume that no other forces whatsoever are acting on it. In reality, there's going to be some air resistance and whatnot. But we're going to look at the idealized situation of projectiles with no air resistance or drag of any sort. So if we fire a couple of shots with our cannon, we can easily see the shape of the trajectories of projectiles. Every time we get this nice arc, which we know and love as a parabolic shape, right? Now you might just have, if you started up here and shot down there, you might have a segment of a parabola, but projectiles trace out parabolic paths is an important concept to know about projectiles. Okay, some other examples of that. If you look the next time you're watching some fireworks, if you look at the paths of individual streamers, I guess you could call them, they are projectiles, so they are following parabolic paths. Here's some sparks flying off, also following parabolic paths. Some fountains, you will see parabolic paths, some more fireworks. And once you start looking, you'll see these things all over the place. In sports, now there are, curveballs and things like that, but a pop fly that follows a nice parabolic path. And baseball players learn to kind of intuitively calculate where that end of the parabola is going to be. If it's like a path kind of like this, if it's a high fly ball but it's not too far from home plate, they're going to move in because they know it's going to come down steeply. If it's far from home plate and taking a trajectory more like this, they know they'll need to head backwards. Alright, here's another example. I showed this back in physical science. Some of you might remember this. A DA All-Star here shooting a nice air ball. But we could see the path of this ball was, once again, parabolic. And if we use Logger Pro and if we kind of click on the ball at each frame, we'll get a series of dots that obviously show the parabolas. In addition to that, what I have drawn on here are these red arrows are the velocity vectors at different points along the trajectory. So you can see that the velocity changes direction and it slows down and gets faster as it falls, as we would expect. But the interesting thing is, if I take this vector, any vector can be broken up into its components. Basically, its horizontal part, how far I went horizontally and how far I went vertically. And you'll notice the vertical arrows, as the ball goes up, they get shorter until the peak here, and then they start getting longer. So that means I'm slowing down on the way up vertically and I'm speeding up. So vertically we have a downward acceleration, so that when we're moving this way we get slower and we're moving that way we get faster. Interestingly though, horizontally what's going on is we've got constant velocity in the horizontal direction. And we haven't discussed it yet as far as forces are concerned, but there's no horizontal force, so there's nothing to change the horizontal component of the velocity. Even though the total velocity does change, that's because the vertical component is changing. So these are important concepts that we are going to apply when solving problems regarding projectile motion. And just to summarize the things you should know, they follow parabolic paths. The vertical and the horizontal motion can be analyzed independently. So we can have acceleration vertically as I mentioned here, and still have constant velocity or no acceleration horizontally. So the two don't affect each other and can be analyzed completely independently, almost completely. We do have to have the same time intervals that we're analyzing the vertical and horizontal motion. So these are the concepts you need to be aware of. Next video I'll show you some problem solving. Thank you.